Hello class, today we're working on chapter 1, lesson 6, converse of the Pythagorean theorem. So why learn this? You can use the converse of the Pythagorean theorem to determine if a triangle is a right triangle. Notice the segments to the left below do not form a triangle. The segments on the right below do form a triangle. The length of the three segments must be related in a special way in order to form a triangle. So of course we are remembering that our Pythagorean theorem is the equation a squared plus b squared equals c squared. If that does not work, it does not equal a right triangle. So triangle inequality theorem. That is, the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So looking at this triangle up above, if we went 5 plus 5 equals 10, that's greater than the 8. So that is correct. If we were to do 5 plus 8 equals 13, that's bigger than the 5. And then, of course, the other side is 5 too, so that works. So that's the triangle inequality theorem. Is it possible to construct a triangle with the given lengths? So to try that, we want to add up each length. So 6 plus 5 is 11, which is greater than 4, so that's good. If we did 5 plus 4, that equals 9, and that's greater than 6. And if we did 6 plus 4, it equals 10, which is greater than 5, the other side. So yes, you can construct a triangle with those sides. Let's check this other one. So if we go 7 plus 15, that's going to equal 22, which is bigger than 6. If we do 7 plus 6, that equals 13, which is not bigger than 15. So this one automatically is no. You cannot construct a triangle out of that because 7 plus 6 equals 13, which is not bigger than the other side. That is 15. Try these next two on your own and then come back and let me know. Check your answers with my work. So the first one, 6 plus 10 equals 16, which is smaller than 20. So therefore, automatically we know, no, it cannot make a triangle. The second one, when you add all the sides up, each side just 2 at a time, it's always bigger than the third side. So therefore, yes, it can form a triangle. So identify a right triangle. So a squared plus b squared equals c squared. If that's true, then the triangle is a right triangle. So we have our first example here. 4.5 squared is one leg, 6 squared is the other leg, and we're saying that it equals, 7.5 squared. So we just need to check to see if that is true. So 4.5 times 4.5 equals 20.25. 6 times 6 equals 36. 7.5 times 7.5, 7.5 squared equals 56.25. So when we add 20.25 plus 36, does it equal, in fact, 56.25? It does. Therefore, this is true. So this is a right triangle. So now let's check number 1. Go ahead and do number 1 on your own. Come back and see if you got it right. If you got yes, 10 squared plus 24 squared equals 26 squared, you are correct. Go ahead and try number 2. Okay, if you got no, 8 squared plus 9 squared does not equal 12 squared, you are correct. So, looking at applying this to real life, a land surveyor determines that a triangular plot of land has boundary lines that are 400 yards, 600 yards, and 720 yards. The 400-yard boundary runs east to west. Determined whether either of the other two boundary lines run north to south. If either of the other two boundary lines run north to south, then the boundary lines must form a right triangle. So use the converse of the Pythagorean theorem. So a squared plus b squared equals c squared. So they took 400 and squared it, plus 600 squares equaled 720 squared. When they worked that out, it came back that the A and B actually equaled 520,000 and C equaled 518,400. So therefore, no, that was not a right triangle and it did not form. One of the borders did not run north to south. So now if we look, a triangular field is 400 yards, 75 yards, and 85 yards. Does it form a right triangle? Go ahead and try that out on your own and see, check back afterwards to see how you did. So if you got yes, you are correct. 40 squared plus 75 squared equals 85 squared. And just to be clear, I always choose the biggest number. The biggest number will always be the hypotenuse. So that's what it's going to equal. The two smaller numbers is always going to equal the square of the bigger number. Okay, so how is the triangular inequality theorem different from the converse of the Pythagorean theorem? Well, the triangular inequality theorem is used to determine if three segments can form a triangle. And then the converse of the Pythagorean theorem is used if you want to determine if it's a right triangle. Okay, got that down. I did draw a right triangle to remind you of exactly what a right triangle looks like. So for 2, 3, and 4, 3 lengths are given. Use the inequality that follows to determine if it is possible to construct a triangle with the lengths, and then explain. So go ahead and try to do those 3 on your own and then come back. So you should have got that number 2 was yes, because the two smaller lengths are greater than the longest. And both number 3 and number 4 are no. The sum is not greater. So the sum of the two smaller is not greater than the longest. So number 5, 6, and 7 are these right triangles. Go ahead and figure those out and see if you are correct. Come back to me when you're done. Okay, so for number 5, you should have got yes. Number 6 is yes, and 7 is no. Your homework for today is page 33 through 34, numbers 9 through 23 odd. Complete that on a new note to submit to your assignments. Before submitting it, please have your parents check over your answers to be sure you are understanding the work.